Welcome to the Bob Bloom Show with your host, Bob Bloom, a production of South LaSalle. Welcome to episode 31 of the Bob Bloom Show, Threads Within a Thread, Goroutines. Today is Wednesday, October 15th, 2025. The Bob Bloom Show is my monthly commentary PHP passion podcast devoted to PHP serverless, published on the first of the month. This is your podcast host, Bob Bloom from Toronto. I organize the Greater Toronto PHP and Laravel Toronto groups. Head to gtaphp.org for info on our groups. It is with deep gratitude that I express my thanks to my intrepid sponsors of my PHP serverless project, of which this podcast is a part of, Toga Erkan and Luca Lia. I also want to thank my family for their amazing ongoing support of my PHP serverless project. Links referenced in this episode are listed in my notes at bobbloomshow.com, episode 31. You can listen to this podcast on my website, RSS, Spotify, Apple, and YouTube. This is my second of 3 sequential episodes about my personal journey into the FrankenPHP app server. In my previous episode, I go over my inability to make heads or tails of FrankenPHP, along with my inability to make heads or tails about the server it is based on, the Caddy server, and ultimately not really being able to make heads or tails, but the programming language that it's based on, Go. This is my third attempt, trying to make sense of it all, an attempt that started badly. The stumbling blocks that thwarted my second attempt were the starting point of this renewed attempt. These stumbling blocks were my lack of low-level technical knowledge, plus my intensely shitty attitude about having to learn the low-level shit, plus the prolific and confusing use of terminology and lexicon, plus my learning process stopped working. In my previous episode, I described the 2 things that powered my personal breakthrough of understanding. Now, I actually gave up, but then I persevered because the PHP Foundation now officially supports FrankenPHP. If this thing is this important to the PHP Foundation, then I should figure it out. And the second thing, which I think was more profound, was changing my learning process. Instead of doing traditional searches and piecing together answers, I switched to ChatGPT. The process of asking questions, getting answers, and following those answers with more questions was amazing. My hunch that I should understand what is a Linux process and what is a Linux thread proved prophetic. And I answered these questions in my August episode titled Threading the Process. I enumerated 4 features of Go that I think are essential to FrankenPHP: Goroutines, the first-party net HTTP package, Go modules, and Go's compilation. I go through the latter 3 features in my upcoming episode. In this episode, I talk about Goroutines. On FrankenPHP's homepage in the Worker Mode section, it says that FrankenPHP relies on Go's iconic feature, Goroutines. It literally says relies on Goroutines. So that's my hint that I need to understand Goroutines. And this is how I understand Goroutines. Goroutines are the mechanism that allows Go to do a lot of things at the same time. There are 3 distinct aspects of Goroutines. The first is prefacing the name of a function with the reserver Go. The second distinct aspect of Goroutines is the scheduler and management mechanism that is in the Goroutine. And the third distinct aspect is the use of the physical random access memory by way of Linux threads. Now, I suppose that all a developer really has to know about Goroutines is that you just put Go in front of the function name. But that's not where I am. I have a real visceral need to understand what is going on. If there's one thing that is apparent from this third attempt to understand FrankenPHP, it's that my vague notions of what these technical words mean are wrong. And the more low-level a term is, the more my idea in my head of what I think the term means is bullshit. So just knowing you have to type the word go, that's just an appetizer. Now, Goroutines use Linux threads. Linux threads reside inside Linux processes. My own definition of a Linux process is that it is a very distinct piece of random access memory. Linux does a lot of management of and accounting for this very distinct piece of RAM. And Linux gives this distinct piece of RAM its own process ID number. I normally think of process, the word process, as a verb, an activity that is progressing in a structured way. But for Linux process, I think of that as a noun. I think of the noun as the RAM because I think that the essential element of a process is the RAM, of a Linux process is the RAM. And I'm okay if you disagree with me. This is just how I have it defined for myself. I think of Linux threads in a similar way. A Linux thread is also a noun. It's a piece of RAM, but a special piece of RAM, a piece of RAM that resides inside a Linux process that has the same RAM. Its RAM is the same RAM as a Linux process, but a little piece of that Linux process. I think of it as a Linux process, it doesn't use all its available RAM. So Linux can squeeze in something else into that process's unused RAM. I can tell you straight off, ChatGPT does not like this interpretation. It thinks this does not precisely describe what's going on in technical terms and could lead you to get off base on what this is. However, to me, this is the gist of what's going on, at least how I understand it, so that's how I'm calling it. Now, Go could absolutely use Linux threads as is to be able to do many things at the same time. The problem is that the way Linux threads are constructed, there's a limit to how many things can be done at the same time, and the things that are done at the same time, the mechanism is relatively slow. Now, to do a shit ton of things at the same time and to do it blazingly fast, Go has its own proprietary system that mimics the Linux thread mechanism. Go mimics Linux threads residing inside a Linux process. Go mimics Linux thread scheduling and thread management mechanisms. Now, mimic is probably not the right word. Maybe I was inspired by or uses it, So the way I see it, they took a very long, very hard look at Linux when Google decided they were contemplating doing a new language. They concluded that the best way to achieve what they needed was to use Linux threads. But how to use Linux threads to achieve their goals? They then came up with the idea to construct a Linux subsystem inside Go. That's how I look at it. They came up with an idea to construct a Linux subsystem inside Go that uses similar concepts as Linux threads. Materials describing Goroutines use the phrase lightweight threads a lot. This phrase confused me, confounded me, frustrated me. ChatGPT uses the word thread to describe Goroutines a lot. I guess because the materials it sources uses this word a lot. I got mad at ChatGPT about its use of the word thread. I asked, ChatGPT, when you are using the word thread, and there was some context, are you referring to the Linux technology? Or are you referring to a generally accepted computer science concept? Or maybe you're referring to a non-Linux feature that may or may not be part of Go? And the answer was, Yes, yes, yes. And kudos, Bob, for discerning these nuances. Gee, thanks, ChatGPT. Now, that answer, that was what opened the floodgate of understanding. And I had a lot of follow-up questions for ChatGPT from its surprise answer. And I also breathed a big sigh of relief because this confusion wasn't just my inability to understand. There was something there, and it had to be understood. It is legitimate for Go to describe it as lightweight threads. The context is usually assumed. Go's lightweight threads reside inside Linux threads. Threads within a thread. Dreams within a dream. And of course, Go's lightweight threads reside inside Linux threads. I want to repeat that. Go's lightweight threads reside inside Linux threads, which of course reside inside a Linux process. So when Go says lightweight, what does that mean? Well, mainly it means that Go threads are very small, so that you can fit a shit ton of them into a single Linux thread. A Linux thread typically requires 2 megabytes to 8 megabytes of RAM. And I'm going to take ChatGPT's word on that. A Go lightweight thread starts at 2 kilobytes. That's kilobyte. Now, the Go thread increases and decreases in size as needed. There's approximately 1,000 kilobytes in 1 megabyte. So you can have thousands of Goroutines in a Linux thread. To understand Linux threads and Go's lightweight threads more deeply, to understand how they operate requires a technical education that I neither want nor need. And if the need arises, I will dive in, because from here, things get very technical. And I think there's diminishing returns right here in trying to figure it out. But if I at some point have to understand it, then I will. My goal right now is just to understand FrankenPHP. It's not to program in Go. I also want to point out that lightweight thread also refers to the ease with which you can create it, because it requires minimal resources to create it. In this sense, creating Goroutines is often described as cheap. Developers are purposefully encouraged to use Goroutines by way of the ease of designating code as being a Goroutine and by making Goroutines cheap to use. Thank you for listening to this 31st episode of my Bob Bloom Show, Threads Within a Thread, Goroutines. My next episode about the net HTTP package, Go modules, and Go's compilation is scheduled for November 1st. You have been listening to a South LaSalle production. Opinions expressed are not necessarily those of South LaSalle, Bob Bloom, nor of the organizations represented. Links and materials discussed on air are available in the show notes for this show. Information contained herein have been obtained from sources believed to be reliable, but are not guaranteed. Podcasts are released under copyright. Rights are reserved. Email correspondence to the attention of Bob Bloom at bob.bloom@lasallesoftware.ca.